Hi there. We're going to move right on into section 2 here of chapter 9 as we work our way toward the finish line of the course. This lesson we look at arithmetic sequences, and notice as we go, keep this in mind, that these arithmetic sequences are nothing more than linear functions. Alright? A sequence is an arithmetic sequence if there is a real number d, such that for every positive integer k, as we move from one term to the next, we have an arithmetic sequence. Let's take a look at a couple examples here. Example 1, 3, 6, 9, 12, 15. We look at these, and as we move from one term to the next, this common difference we have among the terms is 3. If I look at example 2, 10, 20, 30, 40, 50. The common difference here is 10. If I look at another example, maybe something like this. Example 3, negative 6, negative 12, negative 18, negative 24. My common difference is negative 6. Alright, as we subtract 6 each time to move from one term to the next. Couple formulas that you will need to know for the test. The nth term of an arithmetic sequence is the first term plus the number of the term minus 1 times the difference. Now let's think about this a minute, guys. Let's look here at example 1 just for a second, okay? If I'm at the first term and I know my common difference is 3, I'm going to add 3 on here two times to get to the third term. So I'm at the first term, I add 3 once, that gets me to the second term. I add 3 again, that gets me to the third term. So if I want the third term, I know the first term, I'm going to add on 2 values of the difference, and that will get me to the third term. If I want the nth term, and I know the kth term, then just like as we talked in the last section, you take the kth term. Basically, guys, k replaces the 1. It's a kth term plus n minus k times d. That's the common difference. So with that in mind, let's just work a few of these. We've kind of tried to make sense of them there above. And so for examples 1 through 3 here, we are going to find the nth term, the 5th term, and the 10th term of this sequence. Alright, well, notice that the common difference here as we go from 1 to 7, 7 to 13, and 13 to 19, we recognize that our common difference is 6. And so if we want the 5th term, if we're lucky enough to know the 4th term, which we do here, we can just take the 4th term, add the common difference, and so 19 plus 6 gives me 25. Now, if I want the nth term, let's say, I think we can figure this out here. The nth term, a sub n, is equal to the first term plus n minus 1. N minus 1 times my common difference. And so my first term here is 1 plus n minus 1 times d, which is 6. And so the nth term here, if we'd simplify this, what we would get is 1 plus 6n minus 6, or negative 5, plus 6n. That would give me my nth term. And so to find the 10th term, a sub 10 would be a sub 1 plus 10 minus 1 times the common difference, which is 1 plus 10 minus 1 times 9, which is 1 plus, well, 9 times 9 is 81, which is negative 5, plus 6 times Hang on here just a second. Sorry, my common difference is 6, not 9. Not sure where the 9 came from there. So 9 times 6, which is 54, and negative 5 plus 6 times 10 is 54. So there's the value of my 10th term of this particular arithmetic sequence. Certainly, if you have questions, make note of them. Now look what we have here on example 10. They give us the arithmetic sequence, and so we recognize that 4.2 minus 1.5, this will give me my common difference. That's a 7. 3 minus 1 is 2. So my common difference is a negative 2.7. Now we've got the fourth term here. We know that the fifth term is the fourth term plus the common difference. Well, in this case, the fourth term is negative 3.9. The common difference is negative 2.7. And so this gives me a negative 6.6. This is my fifth term. That's my fifth term. And then our nth term is our first term plus n minus 1 times our common difference. Well, the first term here is 4.2 plus n minus 1 times the common difference, which we decided is negative 2.7. So if we're looking for, well, first of all, we can go ahead and expand this. 4.2 minus 2.7n plus 2.7. We've got 6.9 minus 2.7n. And so looking for the 10th term, a sub 10, let's just cut straight to the chase, is 6.9 minus 2.7 times 10. And, well, 6.9 minus 27 gives us 6.9 minus 27, and we get negative 20.1. So there's my 10th term. Okay. Now 12, you're probably thinking, hey, this looks a little funny. This looks a little funny. How can I figure out what's going on here? Well, let's see. If we subtract our two terms here, remember that if I take x minus 3 and I subtract x minus 8, this is going to give me x minus 3 minus x plus 8, which is going to give me 5. And so notice what's happening. Our common difference here is 5 every time. I add 5 to negative 8, I get negative 3. I add 5 to negative 3, I get positive 2. 5 to positive 2, I get 7. So there's my common difference. My fifth term here, we've got the fourth term. We know that a sub 4 equals x plus 7. So a sub 5 equals a sub 4 plus d, which is x plus 7 plus 5, which is x plus 12. There's a sub 5, our fifth term. We about forgot to find our nth term. Let's see here. A sub n equals a sub 1 plus n minus 1 times d. Well, our first term is x minus 8 plus n minus 1 times d, which is 5. So we've got x minus 8 plus 5n minus 5. We've got x minus 13 plus 5n. There's my nth term. And then my 10th term, a sub 10, is x minus 13 plus 5 times 10. So I've got x minus 13 plus 50. and so this gives me x plus 37. So there's our 10th term in this arithmetic sequence. And I give you a couple problems for class discussion. I give you a couple problems to work for homework there. Certainly if you have questions, bring them along. Now, let's take a look at our next example here. We're asked to find a sub 11. Well, the first thing I need to do is find my common difference. And remember that my common difference is found in this case by a sub 2 minus a sub 1. So a sub 2 is 3 minus a sub 1. 3 minus 2 minus radical 2. This gives me 1 minus root 2. There's my common difference. Alright, now let's keep this in mind. Once I've got my common difference, I know that the 11th term is equal to the first term plus the number of terms minus 1 times my common difference. Well, the number of terms minus 1 is 2 plus root 2 plus 11 minus 1 times d, and d here is 1 minus root 2. So let's see what we've got, guys. This is 2 plus root 2 plus 10 times 1 minus root 2. This is 2 plus root 2 plus 10 minus 10 root 2. 2 plus 10 is 12 minus 9 square roots of 2. Arithmetic sequence, we just found the 11th term. Moving along here. Notice what they did. They want us to find the 500th term, and they have given us the 9th term and the 412th term. Well, first of all, we need to find the value of our common difference here. And so what we're going to notice is there are how many terms between 9 and 412? Well, 412 minus 9 times the common difference. That's how many differences there are to get from the 9th term to the 412th. And this is equal to 2971 minus a negative 253. This sound familiar, guys? If we list these as an ordered pair, the 9th term is negative 253. The 412th term is 2971. And so what I'm about to do here is divide by 412 minus 9. Divide by 412 minus 9. And so D equals 3224 over 403, which very nicely works out to 8. So there's my common difference. There's my common difference. Now, keeping in mind that the nth term is the kth term plus n minus k times d. If I'm looking for the 500th term, this is going to be the 9th term, a sub 9, plus 500 minus 9 times d. d is 8. Alright, so a sub 9 is negative 253 plus 491 times 8. And so this gives us 3675 for my 500th term. My goodness, wasn't that exciting? Okay, now let's think about another result. Let's say that I want the sum of the first n terms in a sequence. Alright, and so we have a couple theorems here, or a couple formulas that will get us those. Let's see, though, if we can understand why these might be true. Look at just something very basic. 1 plus 2 plus 3 plus 4. Alright, now we can see that the sum here is 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. Now check this out, guys. This pair adds up to 5, so does this pair of numbers. Okay, I've got 4 terms. If I cut the number of terms in half, I divide that by 2 times the sum of the first and the last, because the sum of the first and the last will always give you the sum of these pairs. It'll work every time for an arithmetic sequence. 2 times 5 gives me 10. Let's expand it just a bit more. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Now check this out. 1 and 10, 11. 2 and 9, 11. 3 and 8, 11. 4 and 7, 11. 5 and 6, 11. Notice that we've got 5 pairs, or 10 divided by 2 pairs. And a sub 1 is 1 plus a sub 10 in this case is 10. We've got 5 times 11, which is 55. Okay, 5 times 11, which is 55. So we can figure out what the sum is here fairly quickly, and of course we've got our 2 formulas here to help us out. But like I've tried to convey this semester, if you can understand why a certain formula or result works, that hopefully will make life a little easier to understand. Here in our next example, we want the sum of the first 20 terms, and so I'm going to take 20 divide by 2. The value of the first term is 5. The value of the 20th term is 9. 20 divided by 2 is 10 times 14. The sum of the first 20 terms is 140. Now, if we look here at our last example in this section, find the sum of the arithmetic sequence that satisfies the stated conditions. Our sixth term is -2, our difference is -3/4, and we've got 40 terms. First of all, we don't know our first term here, so we're going to need to find that. Now we're going to have to ask for help from the formula that says a sub n equals a sub 1 plus n minus 1 times d. Because you see, we know a sub 6, we're looking for a sub 1. We know that 6 is n and that d is -3/4. Alright, a sub 6 we know is -2. This equals a sub 1 that we're looking for plus 5 times -3/4. -2 equals a sub 1 minus 15 over 4. So -8 over 4 plus 15 over 4 equals 7 over 4. There's my first term. Alright, now we're in business. Now we are in business because we can make use of the fact that the sum of the first n terms is n over 2 times twice my first term plus n minus 1 times d. So I've got 40 terms here. The sum of the first 40 terms, 40 over 2, 2 times the first term, which we said is 7/4, plus 40 minus 1 times the difference, -3/4, and so that adds up to -515. And so that puts the wraps on the discussion questions here for, or the lecture for 9.2. You've got some discussion questions to look at and some homework, and we'll certainly talk about anything you have questions on in class.